morning, students. Today we are going to start our subject called Boolean Algebra. Boolean Algebra is a branch of algebra, you can say, that deals with the binary variables as well as the logical operations and logical operation performed on these binary variables. Okay, and they are typically represented by either true or false. Simply saying, and it is basically used to simplify digital circuits and other logical based systems. In 1854, a mathematician called George Boole, he developed this language or this Boolean algebra, this, and it was the foundation of our digital logic design in computer science. This is the basic fundamental of, or it is used as a foundation for Boolean logic design के लिए. There are basically let's first understand the basic concept of Boolean algebra. You have Boolean algebra operates on simply binary values, and it is basically the values will be either 0 or 1 means, and these variable, it simply means in Boolean algebra we have for any variables it can possibly only have two values, either 0 and 1. This 0 represents false and this 1 represents true, or you can say it otherwise, this 0 stands for low and this 1 for high. We can only we use Boolean algebra to perform logical operation. We are not performing any arithmetic operation here. We are simply performing the logical operations, and we have all the operators here like AND, OR and NOT gates for so on. There are so many operations, laws for which do exist in Boolean algebra, but we have the fundamental there are three fundamental operations which we have included in you can say Boolean algebra. The basic operations are, first one is negation, then we have conjunction, and last one is distinction. Let's first understand the first basic operation or a fundamental operation, that is not or negation. We represent it by either using dash or this tilde sign, and it is doing nothing but it is inverting our input, means 0 will become 1, and if we are performing not operation with 1, it will become 0. The output will be 0. It is represented by the, normally we represent it by the bar on the variable, means simply I can write it as a bar. And let's first understand the truth table for this negation operation. If we have a is having a false value, then the not a or a bar will be 1, or you can say true. If the a is true, then not a will be, this will also be, simply you can say it will be 0, or you can say it is false. It is simply doing nothing but inverting the values of initial variables, means for any variable a, it will have only, it can possibly have only two inputs, either 0 or 1. Not of 0 will become 1 and not of 1 will become 0. Next we have AND operation, or you can say it is conjunction. We simply represent it by the dot symbol, and normally most of the time we simply write AB, we simply omit this dot sign also, but in general we write it as A dot B. The truth table, let's first understand the truth table for this AND operation. It is, the output will be 1 only if both the inputs are 1. Otherwise the output will be 0. Means if any one of the input will be 0, then the output will be 0. Means if any one of the input is false, then output will be false. It will be true only only when both the inputs are 1. Let's go through this truth table. We for 2 input, we have 2 to the power 2, that is 4 input possible combination. First combination is 0 0, then we have 0 1, then we have 1 0, and at the end 1 1. When A is 0, B is 0, output will be 0. When A is 0, B is 1, A and B will be 0. If A will be 1 and B is equals to 0, then the A and B value will be 0. If both the input are high, means if A equals to 1, B equals to 1, then the value of A and B, this logical operation, will be 1, or you can say high. Next we have the OR operation, or you can say it as disjunction operation, that is performed on Boolean algebra. And the basic symbol is, the basic we write it represented by the plus symbol, and the output is 1 or high if at least one input is high. Means if any one of the two inputs is having high value, then the output will be high. Simply we are using plus sign, or it is denoted by these two signs. And then let's understand the truth table for this one. What you have is, first one, if A and B both are having 0 value, then the A or B will be 0. If A is false, B is true, then the output will be true. If any one input is true, then the output will be true. In this case, A is true, B is false, the output is also true. In last case, both the input are 1, then the output will be high, or you can say it will be 1 or true value. Let's first understand the basic application area first of Boolean algebra. That if we are learning about Boolean algebra, then why we are using it? What is the need to understand these logical operation? The first basic operation of or application area of Boolean algebra is, it is used to design, you can say it is used to design and analyze the Boolean circuit, basic Boolean circuit, and you can say simply the logic gates also. Next, it is basically used in the area of computer programming. We are using conditions and logical programming. So you can simply say where we are using circuit, we are designing circuits. Then it is also used in you can say set theory. Because Boolean algebra can be seen as a way to represent and manipulate sets and their operation, like for example union, intersection, and complementations. So it is also used in set theory. It is also used in data encryption and security. The basic application area of Boolean algebra is also it is also helpful to design some search engine algorithm. Let me give you a basic hint of what the next lesson will be, because in our next lesson we will try to understand Boolean algebra's laws. What are the basic Boolean laws, whether it is null laws, complement laws, where we have to perform some distribution understand some distribution law. Next we have De Morgan's theorems, we have identity laws. In our next lesson we will try to prove these laws one by one and try to solve some Boolean operations or Boolean expression, try to reduce these operations. We will try to reduce and try to use these laws to solve our Boolean expressions. Thank you.